Hello, Integrated Math 1. Welcome to lesson 2.4.1c. We're actually on day 3, but this is the last day of this lesson, I promise. We were just trying to break it up a little bit more to make it a little easier to manage. So module to topic for lesson 1 on the 3rd day is where we're at. But that means we're only doing activities 1.4, 1.5, and the talk today. So we're going to start off on page M2-258. And we're going to start off by classifying quadrilaterals in the coordinate plane. So in this activity, we'll be classifying quadrilaterals by examining the lengths of their sides and the relationships of their sides, right? Do we have congruent sides? Do we have congruent angles? Do we have right angles? Do we have opposite sides that are sloped, that the slopes are parallel? So we're going to be looking at things like slopes. We're going to be using distance formula. Again, all of that stuff is coming back at us to help us decide what kind of quadrilateral is it? Is it a parallelogram, a trapezoid, a rectangle, a rhombus, a square? What is it? That's what we're going to be working on today. So to get us started, we do need to graph our quadrilateral. It does help to have a quadrilateral on the graph. So step number 1, graph quadrilateral ABCD using the points -5, 6. A is at -5, 6. B is at -8, 2. C is at -5, -2. And D is at -2, 2. So go ahead and hit pause, graph quadrilateral ABC. Make sure you label A, B, C, and D. As you go, it'll make it easier. And then hit play when you're ready to check your work. All right, so let's plot some points. A is at -5, 6. So I went left 5 and up 6, and we'll call that A. B is at -8, 2. So we need to go left 8 and then up 2, and we'll call it B. C is at -5, -2. So that means left 5 and down 2 this time, and we'll call that C. And of course, D is at -2, 2. So that means we have to go left 2 and up 2, and there is D. We do need to connect the dots, right? We got to connect it up. So A, B, C, D, and back around to A again. Beautiful. We have 4 sides. Now, oftentimes we like to glance at things and go, that's what that is, but we're going to prove it, all right? We're going to prove the quadrilateral is what we think it is. So to get us started on that, I would like you to determine the side lengths. So use some distance formula. Use some distance formula to determine the lengths of the sides of quadrilateral ABCD. And can you classify it from the side lengths? And if so, tell me what type of figure it is. And if not, tell me why you can't. So go ahead, do distance formula for all 4 sides, and then hit decide what kind of quadrilateral it is. And then hit play when you're ready to check your work. All right, I don't have numbers on this, so just to make this a little easier, I'm going to write some numbers on here. So we said that A was at -5, 6. We said that B was at -8, 2. We said that C was at -5, -2. And we said D was at -2, 2. So I like to have those numbers handy because it does make it easier to use distance formula. So let's go ahead and start by finding AB. Remember how distance formula works. You subtract your x coordinates, you subtract your y coordinates, right? So -5 minus a -8, and then we'll also have 6 minus 2. Don't forget parentheses, squaring it, plus sign, big square root, but we're going to start with subtracting these guys. Of course, if I do -5 minus a -8, that double negative does become a positive. And -5 plus 8 is 3, so this becomes 3 squared. 6 minus 2 is 4, so this becomes 4 squared. And then we work it from there. 3 squared is, of course, 9. 4 squared is 16. 9 plus 16 is 25. And I didn't even need my calculator for this. I was like, I know this one. The square root of 25 is 5, because 5 times itself is 25. Yay. All right, let's go ahead and let's do B now. Let's do BC. So again, subtract my x coordinates, -8 minus a -5. Subtract our y coordinates, 2 minus a negative 2, because I should label x and y. So subtract our x's, subtract our y's. Well, negative 8 minus a negative 5, that's going to become a positive. And that happens over here as well, right? 2 minus a negative 2, the double negative becomes a plus there as well. So negative 8 plus 5 is a negative 3, so this will be negative 3 squared. And 2 plus 2 is, of course, 4, so this part will become 4 squared. And then we just go from there. Negative 3 squared is a positive 9. 4 squared is 16. And look what happened again. 9 plus 16 is 25. And the square root of 25 is 5. Check it out. So far, I've got 2 congruent sides. Wonder that this will keep going. So let's go ahead and find CD then. Let's go ahead and use distance formula on this one. Again, my x coordinate, my y coordinate. So negative 5 minus a negative 2, and then negative 2 minus 2, right? We got x's, we got y's. So that means double negative here becomes a plus. Negative 5 plus 2 is a negative 3, so this will be negative 3 squared. And negative 2 minus 2, that will become a negative 4 squared. Negative 3 squared, of course, gives us a positive 9. Negative 4 squared gives us a positive 16. And look what happened again. 9 plus 16 is 25. The square root of 25 is 5. So far, we've got 3 congruent sides. This is a good sign. Maybe the last one will get there too. So last side, let's find AD. Again, we're going to subtract our x coordinates, subtract our y coordinates. Doesn't matter which one's first. So let's go ahead and do negative 5 minus a negative 2 for our x's. And then we'll do 6 minus 2 for our y's. Of course, the double negative becomes a plus sign. So negative 5 plus 2 is a negative 3 squared. 6 minus 2 is 4 squared. Negative 3 squared is a positive 9. 4 squared is positive 16. And again, 9 plus 16 is 25, and that equals 5. Square root of 25 is 5. Oh my gosh, we have 4 congruent sides. So because we have 4 congruent sides, I know it's a rhombus. I don't know if it's a square or not, but I know it's a rhombus because it has 4 congruent sides. So I do know that. Not sure if it's a square. In order to know if it's a square, I would have to know about its angles, right? I'd have to know about those slopes if I wanted to know if they were perpendicular or not, if I wanted to know if it was a square. So that takes us to part B. I bet you're not surprised. Part B, determine the slope of each line segment in our quadrilateral and then describe that relationship. Are they opposite reciprocals? Are they perpendicular? And this should tell us, is this a square or is it just a rhombus? Tell us what's going on here. Go ahead and hit pause to find those slopes and figure this out, and then hit play when you're ready to check your work. All right, so once again, I've lost my points. I don't really need them, I guess, if I'm just finding slopes. So let's go ahead and find slopes. Let's find the slope of AB. Remember when we do slopes, we go left to right. So it looks like, and notice we're counting by twos, it looks like we go up 1, 2, 3, 4, and then we go over 1, 2, 3. So it looks like the slope of AB, my rise over run, I rose 4 and I ran 3. So there's my slope for AB. Let's go ahead and find the slope for BC. Again, we go left to right. So I'm going to go rise over run. But notice this time I have to go down. So I'm going down 1, 2, 3, 4. So I went down 4. That makes it a negative, doesn't it? And then I'm going right 3, 1, 2, 3. So that means the slope for BC will be negative 4 over 3, right? Because I had a negative, I went down. Let's find the slope for CD. And again, that means I've got to go left to right. So I'm going to go, it looks like I have to go up 1, 2, 3, 4. So I'm going up 4. Then I go over 1, 2, 3. So it looks like the slope of CD, it rise is 4, my run is 3. So my slope is 4/3. So check it out. AB and CD are parallel. That's a good sign. What else do I have here? Oh, we need to do AD, right? So A to D. So I'm going to go, from A to D, I have to go down 4, 1, 2, 3, 4, so it's a negative, and again over 3. So that means the slope of AD is going to be negative 4/3. So A, B, and CD are parallel, and that's not surprising. We know with a rhombus, that's kind of a thing that it does. B, C, and DA are parallel, right? They have the same slope, negative 4/3, negative 4/3. But these guys are not opposite. So our opposite sides have the same slope. But 4/3 and negative 4/3 are not opposite reciprocals, right? They're opposites, but they're not reciprocals. They're not getting that flip thing going on. They're both 4/3. We don't have one of them as 3/4. So none of the slopes have an opposite reciprocal relationship. This means there's no perpendicular lines. There's no right angles here. So it is just a rhombus and not a square. Because in order to be a square, we would have had to have had 4 right angles, and we don't have 4 right angles. Fine, be that way. All right, let's go to another one then. Let's do another one of these. Again, you're going to graph quadrilateral ABCD using points A, 8, 8, B, 3, -7, C, 10, -6, and D, 13, 3. And then, of course, you may want to play with slopes. Maybe you want to play with distance formula. I don't know. You got to decide. Go ahead and classify this quadrilateral. Show me some work. You got to explain your reasoning. Classify this quadrilateral as a trapezoid, a rhombus, a rectangle, a square, or none of them. Go ahead and hit pause, do your thing to graph this and figure out what it is, and then hit play when you're ready to check your work. All right, first things first, we got to graph it, right? So A is at 8, 8, so we have to go right 8 and up 8, and I'll put it there, and I'll give him his little letter A. B is at 3, -7, so we have to go right 3 and down 7. Oh my goodness. And we'll call that B. Wow, that's a long ways. C is at 10, -6, so right 10 and then down 6, and we'll put our little point C there. And D is at 13, 3, so we'll go right 13 and then up 3, and we'll put our little point there. We'll call that point D. Of course, it is a quadrilateral, so we need to connect the sides. A, B, C, D, and back to A again. Yay. You know, just at a glance, just glancing at this, I'm thinking that's not a rhombus, a square, or a rectangle, right? But it's not even a parallelogram, but it might be a trapezoid. Remember how trapezoids have only one pair of parallel sides, exactly one pair of parallel sides? So you know what I'm going to do? Maybe I'm not going to worry about distance formula on this one because my gut instincts are like, it might be a trapezoid. I'm feeling like I should find slopes and make sure there's only one pair of parallel sides. I think that would be way more effective way of doing this. So let's find slopes. So let's find the slope of AB. Again, I'm going to go left to right. So it looks like to get from B to A, I've got to go up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. It looks like I had to go up 15. Holy crud. I had a rise of 15. And then my run, 1, 2, 3, 4, 5. I have a run of 5. So that means the slope of AB is 15 over 5, which simplifies down to 3, right? 15 divided by 5. So that was convenient. Let's find the slope of BC. It's not so big. I'm hoping that'll make it easier. It's not like so far up there. So let's find the slope of BC. It looks like I have to go up 1, and then I run 1, 2, 3, 4, 5, 6, 7. So it looks like the slope of BC is 1 over 7, and there's no simplifying that. It just is. All right, so far, nothing parallel, but that's fair. I mean, those guys are next to each other. We didn't expect them to be parallel. Let's take a look at CD because that's the one. I think that's the magic one. So let's look at the slope of CD. To get from C to D, I'm going to rise 1, 2, 3, 4, 5, 6, 7, 8, 9. Ooh, so I rose 9, and then I ran 3. Wow, my 9 has issues. So I rose 9 and I ran 3. So it looks like the slope of CD is 9 over 3. Oh, sorry, that says 15 over 5. That should say 9 over 3. 9 over 3, which does simplify down to 3. Ooh, so we have at least one set of parallel sides, and we actually don't want the other set to be parallel, so let's check the slope of AD. So to get from A to D, I have to go down. Like it's the first time I've gone down. 1, 2, 3, 4, 5 down, so it's a -5. And then I'm going to run 1, 2, 3, 4, 5 over. So it looks like the slope of AD is -5 over 5. Well, -5 divided by 5 is a -1. So sure enough, it looks like AB and CD are parallel, but BC and DA are not. That's good because that means quadrilateral ABCD with its one pair of parallel sides is a trapezoid. And we didn't just eyeball it, right? We actually found the slopes. We put in the work to make sure we can prove our claim that we can back that mess up. So you guys have gotten pretty handy with distance formula. You've gotten pretty handy with these slopes. But let me throw another trick your way. So you have used the distance formula to determine the distance between 2 points. A midpoint is a point, notice this is bold, this is one of your key terms. A midpoint is a point that is exactly halfway between the 2 points. So distance tells you, hey, distance formula tells you this is how far it is from this point to this point. But the midpoint is the distance exactly halfway between those points. So it slices it in half, right? If this side is congruent to this side, then that means that this bad boy in the middle is our midpoint. And sorry that my pen went funky. Now, there's a way to find this midpoint. To determine the coordinates of a midpoint, you can use something we call the midpoint formula, and it's actually really easy to use. All you have to do is find the average of the x coordinates and the average of the y coordinates. That will give you the middle, right? If you want to know the middle, you got to find the average, right? So fine. The midpoint formula states that if x sub 1 and y sub 1 is one of your points, and x sub 2, y sub 2, these are 2 points on your coordinate plane, then the midpoint of the line segment that joins these 2 points, the point exactly in between these 2 points, is this formula right here. So like I said, we find the average of our x's, we add our x coordinates and divide by 2. We find the average of our y's, we add the y coordinates and we divide by 2. And lo and behold, there is your midpoint. So to give you an idea, this is not going to be my best work ever because I'm making it up on the fly. Let's say that this point is at 2, 6. And we're going to say that this point, and again, it's not to scale, all right, people? We're going to say that this point is at 5, 11. Then if I want to find the midpoint, all I have to do is add my x coordinates together, 2 plus 5, and we'll divide by 2. And then I'll give you my new x coordinate. And for my new y coordinate on my midpoint, I would add my y coordinates together, 6 plus 11, and divide by 2. Of course, 2 plus 5 is 7. 6 plus 11 is 17. And you could leave it as a fraction, simplify if possible, or you could write it as a decimal. 7 divided by 2 is 3.5. 17 divided by 2 is 8.5. And these would be the coordinates for my midpoint. There you go. It's actually a really easy formula. There's no squares, there's no square roots. I'm not even subtracting stuff. Like you just add your x coordinates together, divide by 2. There's the x coordinate for your midpoint. Add your y coordinates together, divide by 2. There's the y coordinate for your midpoint. That's all you have to do. It's so nice. So, given square A, B, C, D, we're going to have some fun here. So we're going to use the midpoint formula to determine the midpoints of each side of the given figures. So given square A, B, C, D, here it is, I would like you to determine and label the midpoint of each side of the square. We're not eyeballing it. Use that midpoint formula to figure this out. Go ahead and hit pause. show your work, find those midpoints, and make sure you label them and put them on your square. Go ahead and hit pause to do that. Hit play when you're ready to check your work. All right, first of all, I should figure out what these coordinates are, right? It looks like for B, I went right 5 and I went 0 up or down. So, pardon me, let's start with A. So I went 0 right, so left or right, but I went up 5, so that's 0, 5. For B, I went right 5, no up or down. For C, I did no up or down, but I went down 5, so that's 0, negative 5. And then for D, I went left 5, so that'll be a negative 5, but no up or down, so 0 for my y coordinate. So I just started by writing down my coordinates. It makes things easier. So I'm going to find the midpoint. Let me grab my pen here. Let's find the midpoint of AB. So I'm going to add my x coordinates together, 0 plus 5, and divide by 2. I'm going to add my y coordinates together, 5 plus 0, and divide by 2. So I did that. 0 plus 5 is 5. 5 divided by 2 is 2.5. 5 plus 0 is 5, divided by 2, and I got 2.5. So that means the midpoint of AB is at 2.5, 2.5. So I'm going to put my little point there, and I'm going to put my little coordinates there so I can remember, hey, there's my midpoint. Let's do the same thing again for BC. Hey, so again, I'm going to add my x coordinates together and divide by 2. 5 plus 0 divided by 2. Add my y coordinates together and divide by 2. 0 plus a negative 5 and divide by 2. So for this one, 5 plus 0 is 5. Divided by 2 is 2.5. 0 plus a negative 5 is negative 5. And negative 5 divided by 2 is negative 2.5. So looks like I have to go right 2.5, down 2.5, and I'll put my point there, and I'll put the coordinates next to it so I can remember. Let's do CD. I think you're getting the feel for this. I think you're absolutely getting the feel for this. So we'll add our x coordinates together, negative 5 plus 0 divided by 2. Add our y coordinates together, 0 plus a negative 5 divided by 2, which means we end up with negative 2.5 and negative 2.5 for our midpoint. So I'm going to go left 2.5, down 2.5, put my point there, put my coordinates there. Yay, us. Last but not least, let's find the midpoint of that fourth side. You're getting a lot of practice with midpoints. Let's find the midpoint of that fourth side of AD. I think I've got a typo coming up here. Sorry about that. So fourth point for our midpoint for AD. So again, add our x coordinates together, negative 5 plus 0, divide by 2. Add our y coordinates together, 0 plus 5, divide by 2, which means, and that should say AD. Sorry about that. So negative 5 plus 0 divided by 2 is a negative 2.5. 0 plus 5 divided by 2 is a positive 2.5. So it looks like I have to go left 2.5 and then up 2.5. Make my mark, put the coordinates there. Boom. You found the midpoints for all the sides. It was a lot. But you got there. That's what matters, right? So here I have my midpoints. I'm just focusing on the midpoints here for part B because here's what part B wants you to do. Determine the polygon formed by connecting the consecutive midpoints of each side of the square and justify your conclusion. All right, this is what it's telling you to do. We found our midpoints. I would like you to connect the midpoints and tell me what kind of shape it is. But notice you have to justify it. So you've got to give me some numbers, some math to prove that you're right. Go ahead and hit pause. See what you can do with this. Connect it up and then hit play when you're ready to check your work. So first thing I did is I connected it and I was like, let's connect it. The next thing I did is in order to make it easier to work with, I named these points. So I called this E, I called this F, I called this G, and I called this H. You didn't have to do that, but it just was going to be easier for me to find all the things. So this feels squarish. I feel like I have a square within a square, but it does say to justify my conclusion. So I've got to prove that. In order to prove that then, I need to find slopes, I need to find distances, I need to find all the bits. Fortunately, we've got horizontal lines and vertical lines. Well, this is a nice vertical line. So the slope of EF, do you remember? Slope of a vertical line is undefined. Yep. Slope of FG, that's a horizontal line. So his slope is 0. Slope of GH, I have another vertical line. So the slope is undefined. And the slope of HE or EH, I can see it's flat, it's horizontal. So its slope is also going to be 0. Well, but check it out. If you've got an undefined line and you've got a horizontal line, you've got right angles. Oh my gosh. So we've got a whole bunch of right angles here. Right angle, right angle, right angle, right angle. We've got 4 right angles. That's a good sign if I would think it's a square. Ooh, but for squares, it could be a rectangle though with 4 right angles. So we better prove that the side lengths are all the same, right? Because that's how we get a square. So let's count. We don't have to count far. I've got 1/2, 1.5, 2.5, 3.5, 4.5, plus another half gives me 5. So it looks like, well, actually I should do EF first, huh? So half, 1, 2, 3, 4, and another half gives me 5. So EF is 5. Let's go from F to G. A half plus 1.5, 2.5, 3.5, 4.5, plus another half also gives me 5. You could use distance formula, but since they're horizontal and vertical, I'm just counting. GH, well, there's a half, 1, 2, 3, 4.5, plus another half gives me 5. You already see this. And we already did HE. We already said that was 5. We did that one first. So sure enough, all of the sides are 5. That means I have 4 congruent sides. Ooh, so magical. Yeah, I've got 4 congruent sides. I've got 4 right angles. It's a square. So when I connected the midpoints, the polygon formed by connecting the consecutive midpoints of each side of a square is also a square. So you don't have to like write it all out, but guys, if the same process was repeated one more time by connecting the consecutive midpoints of each side of the polygon that we found in part A, what would we get? So we have a square. We have a square within our square. If we did those midpoints and connected it again, what do you think we would get? Go ahead and hit pause, jot down your thoughts, and then hit play when you're ready to check your work. Don't overthink it. So you probably already figured out that if I connect the midpoints of a square, I'm going to get a square, even if it's a smaller square. So the resulting figure would also be a square. Yeah, squares within squares within squares. They're squares. But what if it's a rhombus? So here's what I'd like you to do. You can sketch any rhombus on here you like. Remember, rhombuses have 4 congruent sides, but not necessarily 4 congruent angles. So sketch any rhombus that is not a square, no squares. And I would like you to label the midpoint of each side of the rhombus. So start by making a rhombus. Then find the midpoints of each side of your rhombus. And then, if you connect it up, figure out what it is that you found. Go ahead and hit pause. You got a bit of work going on here. And then hit play when you're ready to check your work. So my thought on how to sketch a rhombus is I thought, okay, well, I'll just go up my y-axis and down my y-axis the same amount. And then I'll go on my x-axis, right on my x-axis and left on my x-axis the same amount, but different than what I did on my y's. So I decided to go up 6 here, and then I decided to go right 4 on my x-axis. So that means I need to go down 6 on my y-axis, and I'll go left 4 on my x-axis. You may have done this a little differently, but my brain was like, that's just an easy way to make sure I get a rhombus. So I went ahead and did that, and of course I connect them all up. Yay. Of course, I labeled them, and I wrote down what the points were, 0, 6, 4, 0, 0, -6, and -4, 0. And I just labeled them A, B, C, D to make it easier to work out. And it does make it easier to work out, because if I want to find the midpoints, 0 plus 4 divided by 2 is 2. 6 plus 0 divided by 2 is 3. So my midpoint is at 2, 3. I went ahead and labeled it E just so I can keep track of it better. I also used a different color to make it easier for you guys to see. So for BC, I did the same thing. Find that midpoint, label it. So 4 plus 0 divided by 2 is 2. 0 plus a negative 6 divided by 2 is negative 3. And so I put my little guy there. I'm going to call this F, and I got my point there. Yay. Let's do this for CD. So negative 4 plus 0 divided by 2 gives us a negative 4. And of course, negative 6 plus 0 is divided by 2 is a negative 3. So I went down. I went left 4. That's not right. That should be a 2. Miss Scott, you and your writing. Oh my goodness. Oh, hang on. I can fix it quick. If you want to check my math skills, I can fix it quick. I'm going to fix it. There. Hang on. I got it. I fixed it. See, it's all better. So that's actually negative 2, negative 3. Uh-oh, I lost all my blue stuff. Where'd my blue stuff go? I lost my blue points, didn't I? That's very sad. Oh, well, we'll get there. And of course, the midpoint of, pardon me. I just have a lot of typos in here today, don't I? Oh my gosh, Miss Scott, what are you doing? And of course, I also needed to find the midpoint of AD. That should say AD. Sorry about that. Wow, I don't know why I really like BC and not AD. So that means that we've got 0 and a negative 4 divided by 2 is negative 2, 6 and 0 divided by 2 is 3. So we'll put our little guys back here where they belong. There we go. All right, so we've got our midpoints, we've got them labeled. I went ahead and also called them E, F, G, H, just to make them easier to work with. You didn't have to do that, but it did make them easier to work with. And so that means, let's connect it up, right? What did we find? So I'm going to connect these up. I'm going to use little thin blue lines there to connect these guys up. It feels very rectangle-ish. So that makes me think we need to find some slopes to figure out if we got right angles, right? Well, if we take a look here, EF is a vertical line. That means its slope is undefined. FG is a flat line, which means its slope is 0. GH is a vertical line, so it's undefined, slope is undefined. And HE is a horizontal line, so his slope is also 0. So sure enough, we know horizontal and vertical lines create perpendicular lines. So sure enough, we've got right angles. Boom, 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 boom. I've got 4 right angles. That's a good sign for a rectangle. But it could end up being a square, so we better double check that. So let's go ahead and check our side lengths. Again, because they're horizontal and vertical, I could use distance formula, but I don't have to. I can just count. So I'm going to count. So EF, 1, 2, 3, 4, 5, 6. EF is 6 units long. FG, 1, 2, 3, 4 units long. GH is 1, 2, 3, 4, 5, 6 units long. And the length of HE, it looks like I've got 1, 2, 3, 4 units long on that. Look, the opposite sides are congruent. But I don't have 4 congruent sides, which means sure enough, EFGH is a rectangle. So when I did a rhombus and the midpoints and I sketched those midpoints together, I got a rectangle. But what would have happened if I did it again with my rectangle? If we did this one more time, what do you think you would get? Go, you don't have to show tons of work, but just what do you think would happen? And you can play with the graph if you like. Go ahead and hit pause, write it down, and then hit play when you're ready to check your work. So I was looking at this, and I was like, I grabbed like a different color. I'm going to grab a different color here. I like purple. And I was like, if I found the midpoints and I connected up those midpoints, oh, that looks very rhombus-y, doesn't it? That's not a very good drawing. Pretend like I did better, all right? Yeah, if the consecutive midpoints of the sides of the rectangle were connected, the polygon formed would be a rhombus. We'd be back to a rhombus again, which is what started it all, right? Fair enough. All right, last little activity, and it's a short one. Talk the talk. Consider the points A at 2, 2, B at 7, 8, and C at 13, 8. You can see I've got part of a polygon here. Could you tell me the possible location for coordinates of a point D that would make this a parallelogram. What would D have to be to make this a parallelogram? You have to do a little bit of work. So go ahead and hit pause, jot down your thoughts on this, and then hit play when you're ready to check your work. Now, we did something similar to this last time, and you had the advantage of having it on a coordinate plane. We don't have this on a coordinate plane, so I had to get a little more creative with this. But I do know that wherever D is out here, if it's a parallelogram, that the slope of AD should be the same as the slope of BC. And so I was like, okay, well, subtract my y coordinates on top, subtract my x coordinates on the bottom. And I realized that the slope of BC is 0. BC is a horizontal line, right? And so I thought, okay, well, that means that AD, that would also have to be a horizontal line. I thought, all right, well, it's got to be horizontal. And my next thought was, okay, well, what is the distance of this, right? I know I'm just coming straight out, but how far straight out am I going? And I thought, well, 8 and 8 are the same, but 7 and 13, well, 13 minus 7 tells me, if I did 13 minus 7, that tells me that the length of this, is 6. And I thought, okay, so no up or down, I'm just going to move 6 units to the right. And as soon as I said that to myself, I thought, if I'm moving 6 units to the right, I just need to add 6 to my x coordinate. And I thought, all right, well, 2 plus 6 is 8. And we're not going up or down at all, so that y coordinate's staying the same. So the coordinates of point D that would make this a parallelogram are 8, 2. Now, I did this as a translation. You may have done this another way, but can you go ahead and describe what you did here? Go ahead and hit pause, write it down, just a brief description of what you did, and then hit play to keep going. So again, I noticed that point C was 6 units to the right of B. So I thought, all right, so D just needs to be 6 units to the right of point A. And so I ended up just adding 6 onto my x coordinate. All right, guys, as always, I hope you found this helpful. I hope you found this useful. If you got questions or concerns, let me know. You can click on the Ask for Help button in your breakout room. Of course, you can also come in and see me during office hours. You know, I'll help you out. And I'll see you later. Bye.